So we're looking at page 13 now. And it's a bit more complicated than an electrochemical cell as far as working out what's going on is concerned. Just like before, we are going to ignore our nitrates and the sulfates and sodium ions and potassium ions. Okay, we won't reduce in solution, and we won't oxidize these either under these conditions. So we have to remember that if they're present, they're just going to be spectator ions. We need to list species present for the anode and the cathode. But I guess the big difference now, or something that we have to consider, is that we can electrolyze the water. Okay, so this is a bit different from our redox reactions. We were doing them in solution, but we weren't really considering a spontaneous reaction with water there. So for the anode, which has a positive charge, and the cathode, that has a negative charge, what we do is we list all the anions for the anode, and we list all the cations. And we and water for both. If it's in solution. Obviously if it's molten, then there's no water present, but just that, not just the anions and the cations, but you need to also remember that water is there possibly reacting, and the strongest reducer oxidizes first. And here the strongest oxidizer reduces first. So these statements are the same as from our electrochemical cells, aren't they? What we were looking there was for stronger oxidizers and stronger reducers. But now what we're saying is that we've got lists of things, there's multiple things that can be present, and so we need to rank them. Okay, we're going to be ranking them, strongest to weakest. And the strongest one will react first. So what do you think that means then? What happens if I run out of the first one?
The second one will start?
The second one will start. And the second one won't start until all of the first one is gone. Okay, so it's a sequential reaction then, depending on what's present. So we've got two more half equations to learn. We've got our oxygen and water half equation for corrosion, but we've got to look now at our oxidation and reduction half equations for water. So I want you to have a look at your formula sheets and find them. Okay, can you see where they are on your formula sheet or on the screen? Can you see them? This one here, where we've got water producing oxygen gas and hydrogen ions. This is the oxidation of water, okay? Because we're going from right to left. And so if we electrolyze water, and this is the oxidation half equation, will that occur at the anode or the cathode? The anode. And down here is my other relevant half equation for water. Here I can see I've got water and I'm producing hydroxide ions and hydrogen gas. So where will this occur? At the cathode. Okay? And you will also notice we're producing hydrogen ions and hydroxide ions. So we can confirm, how do you think we could confirm which gas we've made?
Pop test.
A pop test for hydrogen? What's- Sorry? What flame? Yeah, so you can reignite a smouldering splint in oxygen. And what else could we do then to test, to confirm these reactions? What could we add?
You can use an indicator to test the pH.
Yes, so we could test the pH with the indicator. What would we expect to see the colour of the indicator for the reduction of water? To say universal indicator? Purple. And what would we expect to see for this one where we're producing oxygen? Red. Okay, we have to know those colours as well. Now, what I've been doing for the last few minutes is electrolyzing some water. Just check on it and make sure it's